All right, class. In today's lecture, we're going to talk about conceptual and operational variables. To give you a quick overview, we'll spend some time talking about conceptual and operational variables, and I'll lay out what those are, and then we'll incorporate independent and dependent variables to our understanding of conceptual and operational variables. Then we'll do a couple of in-class exercises. I'll talk about next class. All right, so let's talk about conceptual and operational variables. Before we really get into that, let's make sure we all have a clear definition of what a variable is. So take a moment and think about trying to define what a variable is. Whenever I've asked this in the past, students have a very difficult time thinking about what a variable is, but I guarantee everyone knows what it is once I lay it out to you. A variable is any event, situation, behavior, or characteristic that can take on more than one possible value. So think about a constant can only have one value. A variable can have more than one value. So you go back to your algebra class, in middle school or high school, and you'll know that a variable can take on one value. X could be one or X could be two, depending on the rest of the equation. So variables, anything that can take on more than one value. And we're going to be focusing on two broad categories of variables today: conceptual variables and operational variables. And this is a very important concept in understanding research. So a conceptual variable is an abstract idea that forms the basis of our research hypothesis or our theory. So think about these broad abstract ideas, and the key here is to remember that they cannot be directly measured. So you understand what intelligence is, but you can't directly measure it. You can't kind of get your hands around it, but you kind of know what it is. So the conceptual variable are these kind of broader abstract ideas that we are interested in, but the challenge here is that you can't directly measure these variables of interest. So things like aggression or prejudice or intelligence, anxiety, these are all variables that we care about, but there's no direct way of measuring them. So I like to think about conceptual variables as like a cloud in the sky, or if you're looking at a cartoon, it's like the thought in someone's head. It's something that's there, but you can't easily get your hands around it, right? So think about conceptual variables being a variable on a theoretical level. So theoretically, we're interested in prejudice, right? The question then becomes, so how do you actually measure prejudice in the study? Or if your conceptual variable is anxiety, how do you measure anxiety in the study? So on a conceptual level, we're thinking about anxiety, but the challenge becomes, how do we take that conceptual idea of anxiety and distill it down into something that we can actually observe in a study? So I'm going to introduce an example of conceptual and operational variables. And for this example, we're going to talk about academic performance and self-esteem. So on a conceptual theoretical level, we're interested in understanding the relationship between performance in school and self-esteem. There's a relationship between those two variables. And again, because they're conceptual variables, we can't directly measure it or observe it in a study. So what we end up doing is we develop what's called operational variables. And these are the ways we're going to define these broad conceptual variables in a way that we can then measure or manipulate them in an actual study. So we're going to take these broad concepts and we're now going to have some defined way in which we're going to measure them in a study. So let's think about, say, physical attraction as one of our conceptual variables. How can we measure physical attraction? So how attracted you are to someone else, right? So one way is you could put two people in a room and you can observe how often they look at each other, right? So you can record how long they spend looking at each other, or how close they get to each other. Because if you're attracted to somebody, you're going to move closer to that person. Or you could measure heart rate, like maybe your heart rate's going to increase. So you're trying to find some way in which you can actually measure physical attraction in some form or fashion. Now remember, these are indirect ways of observing these particular conceptual variables. So think back to when we talked about sophisticated empiricism. This would be an example of that. So we can't directly measure attraction, but we can now find ways that will kind of get us indirectly at ways of measuring attraction. So again, heart rate would be a good one. Um, Things like that can kind of help us to indirectly tap into this variable of physical attraction. In terms of like intelligence, you can think about maybe giving them an intelligence test, right? And their scores on the test would be an indication of intelligence. So let's go back to our example of performance in school and self-esteem, right? So those are our conceptual variables. Then the question becomes, how can we operationalize these variables in a study? So again, how can we have some way of actually measuring or manipulating these variables so that we can look at their effects? So for performance, you can look at their GPA, right? Or you could look at the teacher's evaluations of the student, right? For self-esteem, you can give them a self-esteem scale like the Rosenberg self-esteem scale, which is a global measure of self-esteem. Or you can have more specific measures of self-esteem looking at academic self-esteem. It gets at, how good they feel about themselves in regards to academics. But the idea here is you have to find some way to take that broad conceptual variable and operationalize it in a way that you can then measure it in a study. And one important point here is to remember that there are multiple ways that you can operationalize a variable, right? So for academic performance, you could look at GPA, you could look at SAT scores, you could look at teacher evaluations. All of them are going to, on some level, capture that broad conceptual variable, but they probably won't capture all of it, right? And some might be better as measures of that conceptual variable than others. So maybe GPA might be a better assessment of performance in school than, let's say, SAT scores, right? Because SAT scores aren't really getting at performance in school. They're really looking at performance in the future, right? So GPA might be the better of those three, just recognizing that each of those will tap into this construct on some level, some being better than others. An important thing to remember is that a good operational variable must be reliable and valid. So we're going to spend some time later when we get to measurement talking about reliability and validity. But for now, think about reliability is essentially, is your operational variable measuring the same conceptual variable each time? Is it reliably measuring um, the same thing? So my example here is a subway that comes at the same time every day is reliable. So a measure of prejudice, if people give similar responses each time that they report that particular measure, that's a reliable measure. You wouldn't want there to be a lot of fluctuation from one point in time to another because that would indicate low reliability. And again, we'll spend some time talking about reliability later. Validity is your operational variable actually measuring the conceptual variable that you're interested in, right? So if I'm trying to measure anxiety, the question is the way that I've operationalized anxiety actually measuring anxiety or something else, right? So if we go back to our example of physical attraction, right, we could measure physical attraction by looking at heart rate. But heart rate may not necessarily be measuring attraction to that person. It could be a measure of fear or anxiety around that person, right? So if it's a person that you're attracted to, your heart rate might go up. But if you're also scared of that person, your heart rate might go up. So the question becomes, is heart rate actually measuring attraction to that person, or is it measuring fear or repulsion of that person? And that's why it's helpful to sometimes have more than one way of operationalizing your variable, because if you have another way of measuring it along with heart rate, maybe you can understand if it's assessing attraction or fear or anxiety. So, for example, let's say you find that people have higher heart rate when they're around a particular individual, but they also move closer to that individual. That would indicate that most likely that heart rate increase is due to attraction, versus if their heart rate went up and they moved away from that person, right? Because that would indicate most likely that their heart rate is increasing because they are afraid of that individual. So by having more than one way of operationalizing your variable in a study, it can help you distinguish between is my measure actually measuring the conceptual variable that I care about, or is it measuring some other conceptual variable that I don't care about? All right, so hopefully you have a basic understanding of conceptual and operational variables. So now I'm going to weave that into a discussion of independent and dependent variables. Now we've talked about these variables already, so this should be a relatively straightforward discussion, right? So when you're doing an experiment, the independent variable is the variable that you think is having an effect on some other variable. And always remember that the independent variable is what's being manipulated. So the independent variable is the causal variable, right? So for the example I have here, you could manipulate, um, say here, whether people are studying by themselves, studying with one other person, or studying in a group. Sort of manipulating who they're studying with to see if it has an effect on the dependent variable, right? So you want to see is studying by yourself, does that lead to better outcomes than studying with one person or studying in a group? The dependent variable is what you think is being impacted by the independent variable. And while the independent variable is manipulated, the dependent variable is always measured. Okay, so you're measuring the dependent variable to see if it's been impacted by the independent variable. So, for example, with the studying, who you're studying with, some possible dependent variables could be scores on an exam, right? So you can see if people who study by themselves have different scores from people who study with one person versus people who studied with a group of people, right? Or your dependent variable could be anxiety. You can see if people had different anxiety levels depending on who they studied with, right? So you're going to measure anxiety because that's your dependent variable, and so you want to see if you get differences